40. Okay. So if you look at the upper right part of the diagram, if you want to see 40. Okay. So if you look at the upper right part of the diagram, if you want to see something like that, and the delta L is very small, that might take tens or hundreds of days. So that's not practical at all if the pendulum is very well adjusted. But what I think is more reasonable, if we go to, for instance, slide 45,
okay,
is to want to see a few of those wiggles. You see how the electricity and the value of theta interplay together. So I would think we want to observe over 2 or 3 of those events, which means something like 120 hours.
10 days?
Well, 120 hours is what, 5 days?
Okay, 120.
That sort of time, I think, which is marrying the practical with what nevertheless is to see several of the variations in electricity gives you confidence that you really have seen the phenomenon.
This question is very important from the machine vision system because we have to build a system that should be working in a variety of illumination conditions, even working with artificial or natural illumination. And I was wondering if this observation requires the vision system to be working the 24 hours a day.
Well, I think the answer is probably no. What it requires is that the pendulum should work 24 hours a day. But indeed, if we have, in astronomy, it's a usual problem in astronomical observations that we don't have any observations during the day. Here it's the inverse, not having any observations during the night. But if we believe the pendulum is kept on going at night, presumably it's very much less likely that it's going to be disturbed by a visitor or anything. We can hope to see the continuation, and even though we don't necessarily, we haven't seen every bit of the variation, we can see enough bits that it forms a coherent picture and we believe we've understood them. So I think simply, given that it will be obviously more difficult to have floodlights and all those sorts of things, for a first trial we can try going over perhaps a longer period, but only during daylight, and see what that gives. That would be the sensible thing to do. Worry that the pendulum can run continuously, but we don't observe it continuously.
No, that's a nice answer for us.
Yes, I think that's the obvious way to start.
Miguel, Icaza is coming back.
Well, let me first say that it is very interesting to meet the man behind your name or the man behind the book. I have seen one of the slides, I think it's 2 or 3 before the 45, which is connected with the damping on the pendulum. I think that you're speaking of the damping on the buffer as the damping due to the air resistance, and you are also mentioning the resistance due to the wire. When I calculated,
Sorry, go on.
calculation for the pendulum here, I neglected completely the resistance due to the wire, and my figures using the Stokes laws for spheres allowed me to predict that the energy for this pendulum should last approximately 8 hours, meaning that 8 hours later the amplitude should decrease to half. And when we began our experimentation, we saw that the time to decrease the amplitude to the half was approximately 1 hour. So this means that the calculation we made concerning the resistance of the air in fact gave a result 10 times lower than expected. And I had neglected the wire resistance, that the friction due to the wire is approximately 10 times larger than the resistance due to the wire. Excuse me, no. The resistance of the wire is 10 times larger than that of the air. And the reason is that the wire is in fact composed of many threads. And as you drive the pendulum sideways, you impose a displacement of the threads composed in the wire, which absorbs very much energy. So the question I would like to propose you is that that in the slides that I have seen you show for Queretaro, it seems to me that you are calculating an equivalent resistance for the air as for the wire. I am mistaken, possibly?
No, it's slide 38. Can we go to slide 38, please? Okay, so what I have in the picture in the left is a drag coefficient for a cylinder, which is the wire, or for a sphere, which is the bar, as a function horizontally of essentially what the speed is. And when the speed is low, indeed we have Stokes' law with a different numerical factor for a cylinder or for a sphere, where the drag depends on the velocity. But when you get to higher velocities, the drag depends on the square of the velocity. Now, and what really that shows is that for the bar, it's mostly in the regime where the drag is the square of the velocity and not in the Stokes law regime. And if you're continuing those lines down, the straight line at the left down, you can see that the resistance is an order of magnitude or more bigger because you're into the square of the velocity regime, which will therefore give you a much shorter time than the 8 hours that you produced.
Yes.
But what I find from the air resistance, now I put in 4 millimeters as the diameter of your wire. Is that about right?
The diameter is around 7 centimeters. I have forgotten the figures. It was a long time ago, but it's around 80 centimeters in diameter.
No, that's the bob. I put 65 centimeters of the bob, which I think is. But the wire, how big is the wire?
38 meters.
And what's the diameter of the wire?
It is around 6 millimeters.
6 millimeters, okay.
But it is not the wire. It has many. It is composed of many hairs of metallic hairs of steel.
Yes, so
It's of nine thin threads, and each of these threads is composed approximately itself by another 20 hairs. So this is possibly yes.
Well, my suspicion is that indeed the fact that the wire is a wire rope, and not a cylinder, will increase the drag on the wire. But I'm no real fluid mechanician, but my suspicion is that in fact it will be the bob that is the major source of the dampening, even though the wire may be more important than I have estimated there.
Well,
but it will be interesting to make some measurements and see how the pendulum really does decay with time. So to make measurements like the diagram on the bottom right, that will be the real proof of the proof of the pudding, as we say in English. That will show what the physics is.
Well, I'm going to turn this back to Joaquin, so that this talk is finished, and we shall stay working on me with you. So this is Joaquin.
Okay.
Hi, Miguel.
Okay.
Well, I would really like to thank you very much for the time and effort that you have put into giving us this talk. It has been very illuminating, and we look forward for more cooperation between you and or the members of our research team. I would like to ask you to join me in thanking William for his talk. Well, thank you very much to all of you for attending the talk. Thank you very much. All right, William.
Thank you very much.
Okay. Talk to you later.
Okay. Yes, I'll talk to you next week.
All right.
Okay.
Bye.
Bon appetit. Bon appetit.
That's
Another time for dinner, lunch for you, dinner for me. Bye bye.
Well deserved. Thank you very much. Bueno, pues como la atención, disculpen varias cosas de las que nos tardamos un poquito más de lo planeado, y bueno, que yo creo que pues estuvo razonablemente bien. Muchas gracias.